Welcome to ClickMyProject.com. Now we are going to discuss about brain age prediction using convolution neural network. Abstract. Deep learning models trained on MRI brain scans of healthy subjects can be used to predict brain age. Accurate estimation of brain age is important for reliably detecting the abnormal aging in the brain. One way to increase the performance of predicted brain age is through using the multimodal data. Previous research using the multimodal data has been largely non-deep learning based. In this, we have examined the deep learning model that can effectively utilize the several modalities. We found that using multimodal data reduced the mean absolute error of the predicting ages. This is our project flow diagram. First, data selection. Data selection means selecting our data sets, data and loading into our process. Here we have two type of data. One is a CSV file, another one is a MRI scan images, and then data augmentation. Data augmentation is a technique of artificially increasing the training set by creating modified copies of data set using the existing data. And pre-processing. Pre-processing means cleaning our data set and resize. Here we are going to do resize the our brain MRI scan images. And then classification. Here we have used the convolution neural network. It is an efficient recognition algorithm which is widely used in the pattern of recognition and image processing. Here we have used the kernel and applied into the process for each image to produce the output for better efficiency. Next one is a performance analysis and report generation. Our project objective is predicting the brain age. In this module we are going to do this, and then we are going to find the mean absolute error, mean square error for showing the difference between the inputs and outputs. Now we are going to see our project output. Our first module is a data selection and loading. Data selection and loading is a process of selecting the data for our process. Here we have two types of data. One is a CSV file, another one is a MRI scan brain images. Here, and then data pre-processing and data augmentation. Data pre-processing means data cleaning. Here we are going to clean our data set by resizing the images into the same format. And then data augmentation. Data augmentation means increasing our data. It is a technique of artificially increasing the training set by creating the modified copies using the existing data. Now we are going to see algorithm implementation. Here we have used the convolution neural network. We have created the five layers to create our model. First layer is a convolution 2D. Convolution 2D means create kernels that convert with the layer input to produce the tensor of output. And then max pooling 2D works by selecting the maximum value of every pool. And then flatten is used to convert the two-dimensional array into the single-dimensional array. And then dense is a simple layer neuron which receives the input from all neural from the previous layer. These are the layers we have created, and then we are going to check the total number of parameters which is trainable and non-trainable. And then this is our output. Here we are going to find the loss values, mean square error, that is a root mean square error and mean square error, which shows the difference between the input and output. And then these are our sample data, input data, and then this is the data augmentation and data pre-processed data. At last result. This is our result with, for a given brain image. We are going to calculate the age. Thank you.